Now I want to tell you about the first 4 rules of inference that we will be using in our natural deduction system. The first rule I want to tell you about is called modus ponens. Consider this information. Suppose you happen to know that if Pam is punctual, then Quincy is quixotic. Okay, so you know that. If Pam is punctual, then Quincy is quixotic. And you also happen to know that Pam is punctual. Well, obviously then from those 2 things that you know, you can infer that Quincy is quixotic, right? And you can infer that just because of the structure of the argument. You notice you have a conditional here. You have the antecedent is Pam is punctual, the consequent is Quincy is quixotic, and you have a separate sentence, a separate statement that is in fact the antecedent of this conditional. From those 2 things, you can infer that the consequent of that conditional is true. So the structure of this argument here is this here. If P, so just P to stand for any statement, if P then Q, and then P again by itself, so if P then Q, P, therefore Q, the consequent of the conditional. Every argument that has that structure is deductively valid. Every inference of that form follows deductively. It's a deductively valid inference. And it doesn't matter what P is or what Q is, as long as you have the same statement here and here, and the same statement here and here, the argument you get from following this pattern will be deductively valid. In our formal logical system, where we're translating English sentences into this formal language, where we use symbols instead of our English connectives like if-then. So we're using a horseshoe for if-then. The argument structure looks like this: P horseshoe Q, P therefore Q. So again, in our formal language then, that's meant to our formal system that's meant to capture the validity of these various argument structures and just display the structure itself. This is an instance of modus ponens, and we'll use the abbreviation MP to stand for that rule of inference, modus ponens. The next rule of inference is modus tollens. Okay, suppose you know that if Pam is punctual, then Quincy is quixotic. But you also know that it's not the case that Quincy is quixotic. You know that Quincy is not quixotic. Well, what can you infer from that? Well, then you know that Pam is not punctual. It's not the case that Pam is punctual. So notice you have a conditional again here, an if-then sentence, and you have the negation of the consequent of that conditional. From those 2 things, you can infer the negation of the antecedent. You can infer that it's not the case that Pam is punctual. And here's what the structure of the argument looks like then. If P then Q, doesn't matter what P and Q are, but if you know that it's not the case that Q, well then it must not be the case that P as well. So that inference form is called modus tollens. This is what it looks like formally in our formal system. If you have any conditional, any statement whose main connective is the horseshoe, P could be anything. It could be something complex. Q could be anything, could be something complex. So if you have that a statement whose main operator is the horseshoe, and you have the negation of the consequent of that conditional, okay, tilde, whatever you have here, from those 2 things you can infer the negation of the antecedent of the conditional. So it's not the case that P. So if P then Q, not Q, therefore not P. Again, a deductively valid argument structure. Every argument that has this form, either in English or in our formal language, every argument that has that structure is a deductively valid argument. Next argument structure is hypothetical syllogism. So suppose you know that if Pam is punctual, then Quincy is quixotic. And you also know that if Quincy is quixotic, then Reggie is rad. Well, from those two things, you can infer that if Pam is punctual, then Reggie is rad. In other words, you have a conditional. You have two conditionals. And the second conditional, you notice the antecedent of this conditional is the same as the consequent of that conditional. So from those two things, you can infer a conditional where you go from the antecedent of the first to the consequent of the second. So you skip this middle, this shared part. So you get, if Pam is punctual, then Reggie is rad, which is what we have here. So the form of the inference pattern is if P then Q, if Q then R, so if P then R. So if P then R. And that's called hypothetical syllogism. This is what it looks like in our formal system. P horseshoe Q, Q horseshoe R. So you have a conditional, you have a statement whose main operator is the horseshoe, another statement whose main operator is the horseshoe, and you notice that the consequent of the one is the same as the antecedent of the other. You can skip that shared part, that common part, and get the conditional if this antecedent, P, then that consequent, R, if P then R. So that's hypothetical syllogism. Again, a valid rule of inference. Any argument, any inference that has that structure is a deductively valid inference. Next rule of inference, disjunctive syllogism. So suppose that you know that either Pam is punctual or Quincy is quixotic. You know that one of those is true. At least one of those is true. Either Pam is punctual or Quincy is quixotic. But you know that Pam is not punctual. It's not the case that Pam is punctual. Well, since the disjunction tells you that one of these two things is, at least one of these two things is true, and this premise tells you that first disjunct of this disjunction is not true, well then the other disjunct must be the true one. Okay? So Quincy is quixotic. So the structure of this argument is either P or Q, not P, so you have a disjunction. You have the negation of the first disjunct. From those two statements you can infer the other disjunct. Not its negation, but the other disjunct. Either P is true or Q is true, but P isn't true, so Q must be true. So that's disjunctive syllogism, and this is what it looks like in our formal system. You have a disjunction, P wedge Q. You have the negation of the first disjunct. You have tilde P. And from those two things, you can infer the other disjunct, Q. And again, it doesn't matter what P is or what Q is or how complex they are. Taking any subsentence, call it P. Any subsentence here, Q, if you have the negation of P, you can, from these two things, you can infer Q, the other disjunct. So those are our first four rules of inference. Every argument of these structures is deductively valid. These are valid argument structures that you can demonstrate to be valid using truth tables, actually. So in the next video, I'll show you how to use these rules of inference in our natural deduction system.